Today we're going to be talking about physical properties of density. So density is the amount of compactness that an object has. It's the consistency of the material. So the unit that we're going to talk about is going to be grams per centimeter cubed or gram per milliliter. And the reason why that is because we have mass, and we know that the unit for mass is either in grams, and we are also measuring the volume. And we know the volume can be measured in milliliters or centimeters cubed if it's a solid. So density does not change regardless of the size of the object, because the physical property. So even if we cut the object in half and it's a completely different size, then it doesn't matter because it's still that property of that substance. So the formula for density is mass divided by volume. So when we talk about density, you're going to be introduced to a brand new subject called the magic triangle. So the magic triangle looks like this. So I want you to draw a triangle on your paper. And on the magic triangle, it will give you the formulas. So we've got density over here. So we're going to put a D for density. We're going to have an M for mass. We're going to have a V for volume. Then, whichever one you're solving for, you cover it up and it gives you your formula. So if you're solving for volume, you will cover it up and you have mass divided by density. If you're solving for density, you cover up density and you have mass divided by volume. And if you're needing mass, you'll cover mass up and you have mass or density times volume. And we'll do some practice problems in a little while. So over here, mass we know is measured in grams. So you can use a scale, a triple beam balance, or a digital scale. Volume is going to be measured in milliliters or centimeters cubed, depending on the method that we're using and what we're going to be measuring. So finding the volume of a solid. So in order for us to find density, we first have to find volume and mass. So to find the volume of a solid, we know there's multiple different ways we can do that, and here are the formulas. So if it's of a rectangle or a cube, we can use length. So length times width times height. And we can solve for volume. If it's of a cylinder, it's pi times r, which is the radius. So we have radius squared times the height of the cylinder. And then we know that volume of a cube is going to be measured in centimeters cubed. That's our units. And we use a metric ruler to solve for this type of volume. So that's when we're finding volume of like a regular solid. When we have to find the volume of an irregular solid, we're going to have to do something different. But let's do an example of finding the volume of a regular solid. So what we're first going to do is we're going to write know and need. And we're going to do that on any type of math-like equation when we do this in here. So we're going to write know. We're going to write need. Well, I know that the question says, what is the density of a 15-gram box measuring 10 centimeters by 5 centimeters by 2 centimeters? Well, I know that G is mass. So I know that M equals 15 grams. Now, I keep reading and I say it says measuring 10 centimeters by 5 centimeters by 2 centimeters. Well, that means that my volume is not given to me, but I can find it using that formula that we used previously. So I know volume equals, let me get a little bit larger tip pen, is length times width times height. So when I do that, I can do my 10 centimeters times my 5 centimeters times the 2 centimeters. And when I multiply those all out, I have 10 times 5, which is 50 centimeters, times my 2 centimeters. So I have 100 centimeters cubed. Then I can solve for density because I know that I have mass and volume. Well, I can use my magic triangle. So I'm going to draw my magic triangle over here. And I have density, mass, and volume. I need density, so I'm going to cover it up. And it gives me my formula. D equals mass over volume. So that's my formula that I'm going to be using. So then I just plug in my information that I know. I know mass was 15 grams, and I know that 100 centimeters was my volume. So now I can just divide these out. So let me pull up a calculator. Okay. So when I divide out fractions, I'm going to take what's on top. So 15 divided by, where's my divided by? My fraction, 100. I'm going to hit equal. So then I've got 0.15, and I'm going to take all of these units with me because none of them can cancel. So now my units are grams per centimeters cubed. And then I'm going to circle my answer. So the density of this box is 0.15 grams per centimeters cubed. So finding the volume of an irregular shaped solid, we know to use water displacement. So we're going to use our graduated cylinder. We're going to put the water into our graduated cylinder. Let's actually change the color. So we put our water into our graduated cylinder. Then we drop our object in. The water will then rise. And we will subtract the volume. So we had 60 as our final volume. So our VF, V sub F was our final volume. And then our initial volume was 40. That was V sub I. We subtract those and we have 20 as our volume of whatever that object was that we put in there. And we know that we find it in milliliters. So we can find the volume of an irregular shaped solid using water displacement. So we can take that volume and we can put it towards finding the density of an object. So here's our example of doing this. So we're going to start out by doing the exact same thing that we did before. We're going to write our know, and we're going to write need. And then we're going to read our problem. So it says a sample of aluminum is put into 10.5 milliliters of water. If the water rises to 13.5 milliliters when the aluminum is added, what is the density of the aluminum if it has a mass of 8.1 grams? So I know that's a lot of information and it can kind of feel overwhelming. But what we're going to do is we're just going to take it step by step, and we're going to go back through and read each section to help us break down this word problem. So the very first thing that it says is a sample of aluminum is put into 10.5 milliliters of water. So that means I know that my initial volume, my V sub I, was 10.5 milliliters. Then the next thing it says, if the water rises to 13.5 milliliters. So what that's saying is we had a graduated cylinder, and our first amount of water that we had in there was 10.5 milliliters. Then we put the object in the water, and the water then rose to the 13.5 milliliters. Well, just like we did in the last problem, we know that our V sub F is the 13.5 milliliters. Now, we know the volume. We have two different volumes, but we need the ultimate volume of this object. We don't need the volume of the water. We need the volume of that object. So to find the volume of the object, we're going to have V sub F minus V sub I. And when we do that, we're going to take our 13.5 milliliters, subtract the 10.5 milliliters, and get 3 milliliters for our object. Well, we also know in our next sentence it says, what is the density of the aluminum if it has a mass of 8.1 grams? So that means I know my volume, I know my mass equals 8.1 grams. So I'm solving, or I need density. Well, using my magic triangle, I cover up density, and my formula is D equals M over V. So now I just plug in my information. I've got my mass, which is 8.1 grams, over my volume, which was 3 milliliters. I'm going to bring my calculator back up. So I've got the 8.1 divided by 3, and it's 2.7. And I'm going to carry all of my units over because none of them cancel. So my units are grams per milliliter. And I'm going to circle my answer. So those are the notes for density. Come back for the next video for some of the practice problems.